All right. Next question. Question 2. So apparently this is a geometric series. So if you want to find the sum of geometric series, usually first of all find its common ratio, right? So the common ratio is the ratio between any two adjacent terms. For example, I to the power of 6 over I to the power of 4. So the common ratio is I squared, right? And usually you can use a letter S to denote the sum that you want, which is I to the power of 4 plus I to the power of 6 plus all the way up to I to the power of 998, and then I to the power of 1000. Then we multiply both sides using I squared. So I squared times a S equals I to the power of 6 plus I to the power of 8, and then all the way up to I to the power of 1000, and then I to the power of 1002. And we can label this with 1 and 2 respectively. Then we can use the first equation subtracted by the second equation, and then this will give us S minus I squared S equals I to the power of 4 plus I to the power of 6 plus dot 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 plus I to the power of 998 plus I to the power of 1000. Then subtracted by the second sum, which is I to the power of 6 plus I to the power of 8 plus till I to the power of 1000 and I to the power of 1002. And then the left side common ratio is S, so we can put it in front, and what's left behind is 1 minus I squared. And right side, note here we can cancel I to the power of 6 all the way up to I to the power of 998, and then I to the power of 1000 with all the terms behind. So right side becomes I to the power of 4 minus I to the power of 1002, right? Okay, so left side, because I squared is minus 1, so now left side is 2s equals the right side. Right side, because I squared is the common factor, which we can put in front, and what's left behind is I squared minus 1I to the power of 551. Sorry, usually will not do it like this. So I to the power of 4 is I squared then to the power of 2, right? And then I to the power of 1002 is I squared to the power of 551. So this means 2s equals I squared is minus 1, so minus 1 squared is 1. And then minus 1 to power of even odd number is negative 1. So this gives us 2s equals 2. That means s equals 1. Okay. All right, so please have a look at this. Do you have any questions? No? All right. No questions. Let's have a look at question 3. Express each of the following as a standard form complex number. So standard form complex number has the form a plus bi, right? So we need to convert each of the expressions into a form like this. So for the first question, the key is to find is conjugate number of the denominator, right? Which is 7 minus 2. And denominator is 7 plus 2i, then 7 minus 2i, right? And in this way, according to the formula, the denominator is a squared minus b squared, which is 49 minus 2i squared. And the numerator, we can just expand it using the distributive law, right? So this is 42 minus 7i minus 12i, then plus 2i squared. And numerator is 42 minus 2, then minus 19i, right? And denominator is 49 plus 4. So this is 40 minus 19i over 53, which gives us 40 over 53 minus 19 over 53i, right? Oh, you were too. Okay, second question is, okay, note here we only need to multiply both sides using an I, right? So this is 5 minus I times I over 3i times another I. And the numerator is 2i minus 5i squared over 3i squared. And then after simplification, this is minus 3 in the denominator, and numerator is 5 plus 2i, right? And in form of a plus bi, this is minus 5 over 3 minus 2 over 3i. Okay. Any questions? No. All right, let's have a look at the next one. Question 4. The number 6 plus 10i can be factored into the product of 3 plus 4i. And what are the complex numbers? So in algebra, if you don't know the other quantity, usually we'll use a letter to denote it, because the other number is a complex number. So usually we'll use a plus bi to denote the unknown number, right? So basically, according to the question, 6 plus 10i is a product of 3 plus 4i and the other complex number, which is a plus bi, right? And the task for us is to find the values of a and b. So note here, a and b are all real numbers. And this actually gives us 6 plus 10i equals, we can just expand it using the distributive law, right? So the right side is 3a minus 4b, and then plus 4a plus 3bi, right? This means we have two complex numbers that are equal. So the real part of the left should equal the real part on the right. And at the same time, the imaginary part on the left should also equal to the imaginary part on the right, right? And this gives us 6 should equal 3a minus 4b. And then 10 equals 4a plus 3b, right? Okay, so basically we need to solve a system of linear equations, right? So note here, both of the equations here are linear. So linear equations, we have already know how to solve them. First of all, for the first question, so note here, it is easier to eliminate the b here, right? So if you want to eliminate the b, we can multiply the first equation using a 3 to both sides. This is 18 equals 9a minus 12b. And for the second equation, we can multiply both sides using a 4. So this will give us 40 equals 16a plus 12b, right? And this gives us, if we label this with a, 1 and 2, we can just use 1 plus 2, which gives us 58 equals 25a, which means the value of a is solved to 58 over 25, right? So let's label this with 3 and this one with 4. Then we can just put 3 into 4 to find the value of b. And this means 6 should equal 3a, which is 3 times 58 over 25 minus 4b, right? And as you can see here, there is only one unknown quantity, which is 4b. So 4b equals 3 times 58 over 25, and then minus 25 times 6, right? Which is 174 minus 150 over 25, which is 24 over 25, okay? And now, as you can see here, we have our A and our B, right? So that means, oh, sorry, this is not B, this is 4B. So we need to do it a step further. So that means B is 6 over 25, right? This is the value of B. Okay, so as long as we have all A and B, the other complex number is known to be A plus BI. So this means 58 over 25 plus 6 over 25i is the other number you're looking for, right? Okay, please have a look at the solution. And any questions, let me know. Right? If you don't have any questions, let's move to the next one. Okay, this time we are given a equals to this expression, and we want to find 3 over 2a minus 4 in a standard complex form. Okay, again, a standard complex number form has form of m plus ni, right? So let's start with the expression here, 3 over 2a minus 4. And we can just put a into this expression and then simplify. So this is 3 over 2 times a. A is 2 plus 3i squared over 5 plus 4i. And then minus 4. And this is 3 over, so note here 5 plus 4i can be moved up. And denominator is twice of 2 plus 3i squared, right? And then subtracted by 4. Okay, and then let's expand the numerator and denominator. Numerator is 15 plus 12i over twice of 4 plus 12i minus 9 minus 4. This equals 15 plus 12i over twice of minus 5 plus 12i, right? And then subtracted by 4. And this equals the numerator now, let's just copy that. And denominator is -10 minus 24i and then -4, right? And here we have come to a point that we need to rationalize the denominator. So again, the key is to find the conjugate number of the denominator here, which is -10 plus 24i, right? Remember the concept of the conjugate number. You can simply keep the real part unchanged and convert the imaginary part to the opposite number. So that means we need to multiply both the denominator and the numerator with -10 plus 24i. Don't forget the, oh, I'm sorry for this. I think it's better to rewrite the whole expression using the common denominator here. So you can do either way, but I think this way is much easier. So the common denominator is -10 minus 24i, and then 15 plus 12i, and then -4 times -10 minus 24i, right? Okay, next let's simplify the numerator, which is 15 plus 12i plus 40 plus 96i, right? Over -10 minus 24i. And this should equal 55 plus 108i over -10 minus 24i. Okay, so here we have come to a point that we need to rationalize the denominator. The key is to find the conjugate number of the denominator, which is -10 plus 24i, right? Okay, now let's expand the numerator and denominator respectively. So the numerator is -550 plus 1320i, then -1080i minus 2592 over the denominator, which is a squared minus b squared, which is 100 plus 576. And this gives us -3142 plus 240i over 676. And the final result in the form of a plus bi should be minus 1571 over 338 plus 60 over 169i. Do not forget to cancel the common factors, right? So although the number seems a little larger, but the underlying principle are the same with the questions we have done, right? You can just follow the simple arithmetic rules. Any questions? Okay, and then let's move to the next one. All right, again, there's nothing tricky here. We can just follow the simple arithmetic rules. If you want to find the reciprocal of x squared plus x, let's just put x in this expression. But first of all, I think it's better to do it like this. X times x plus 1. Otherwise, you have to find squared x first, which is not very easy to compute. So in this way, we'll just put x in the expression. So x is 1 minus 2i times square root of 3 over 4, right? And x plus 1 is 1 minus 2i square root of 3 over 4 plus 1. And this is 1 over 1 minus 2i square root of 3 over 4 times 5 minus 2i times square root of 3 over 4. And then we have, so note here, 2 4s here can be moved up. So 4 by 4 divided by 1 minus 2i square root of 3. And then 5 minus 2i square root of 3, right? And now the denominator is 16. And the numerator, the numerator is 16, and denominator we can just extend it, which is 5 minus 2i square root of 3, and then minus 10i square root of 3, right? Plus 4i squared times 3. And this is 16 over 5 minus 12 minus 12i square root of 3, which can be combined to minus 7 minus 12i square root of 3, right? So again, we have came to a point that the expression here needs to be rationalized. And note here the conjugate number of the denominator is minus 7 plus 12i times square root of 3, right? So again, let's multiply both numerator and denominator using the conjugate number, which is minus 7 plus 12i square root of 3 over minus 7 minus 12i square root of 3, then minus 7 plus 12i square root of 3, right? Okay, next, the numerator now is minus 112 plus 192i times square root of 3. And denominator now is 49 minus 12i square root of 3 squared. Okay, and copy the denominator, copy the numerator now. And the denominator now is 49 plus 144 times 3, right? Okay, this is minus 112 plus 192i square root of 3 over 481. And in the form of a plus bi, this is minus 112 over 481 plus 192 over 481 I square root of 3. Okay, so please have a look at the solution here. And if you haven't done it correctly, please correct it now, okay? I'll give you some time. All right, if you finish, let's have a look at the last question. All right, question 7. Find all complex numbers a minus bi, where a and b are real numbers such that the conjugate number of a minus bi equals 2a plus bi squared. Okay, again, first of all, we need to simplify this equation, right? Otherwise, if you have a conjugate number, a conjugate sign here, it's not very easy to solve. So the original equation is a minus bi conjugate equals squared of 2a plus bi. Okay, so this is equivalent to the left side is just a plus bi, right? Because the conjugate number means the real part unchanged and imaginary part converted to the opposite number. And the right side, we can just expand it using the formula, which states that it should be 4a squared plus 2ab. 2ab is 4abi, right? And then plus b squared, which is b squared I squared. So note here, I squared is -1. So we can further rewrite the equation to a plus bi equals 4a squared minus b squared. And then plus 4abi, right? And now we have come to a point that two complex numbers are equal. That means the real part on the left should equal the real part on the right. And at the same time, the real part on the left, the imaginary part on the left should also equal the imaginary part on the right. And this is equivalent to, first of all, a equals 4a squared minus b squared, right? And then b equals 4ab. Okay, so now we have a system of two equations, right? Two unknown quantities with two equations that should solve those two unknown quantities, right? So first of all, let's simplify the system. First equation is equivalent to 4a squared minus a minus b squared, right? And second, note b is a common factor, right? So if you put 4ab on the left, or put b onto the right, you will get 4ab minus b is 0, and b is a common factor, so b times 4a minus 1 is 0, right? You follow me? Okay, so usually we'll start from the easier one, which is the second equation, right? Okay, so let's label them first. First equation, second equation. So we can start from the second equation. Second equation tells us that a product of two numbers, number 1 and number 2, right? A product of two numbers is 0. That means we either have the first number b is 0, or the second number 4a minus 1 is 0, right? Understand? And 4a minus 1 is 0 is actually a is 1/4, right? Okay, so that's the information we derived from the second equation. So now we need to discuss. There are two possible branches, right? So if first of all, if b is 0, what does it tell us? If b is 0, we can put b is 0 into the first equation, right? So that means 4a squared minus a minus 0 is 0, right? And it further tells us a is a common factor which can be put in front, and then times 4a minus 1 is 0, right? And again, the product of two numbers is 0. That means a is 0, or 4a minus 1 is 0. That means a is 1/4, right? Okay, so we have discussed what will happen if b is 0. And remember, there is another branch. That means you need to discuss what will happen if a is 1/4 here, right? If a is 1/4, let's just put 1/4 into the first equation. This time is 4 by 1/4 squared minus 1/4 minus b squared is 0, right? And you can see here we can solve b. So this is 1/4 minus 1/4 equals b squared, right? So that means b squared is 0. That means b is 0, right? Okay. Let's move this a little bit downer. So from the first branch, we know that if b is 0, a is either 0 or 1/4, right? So the solution of the first branch is b is 0 while a is 0, or second set is b is 0 and a is 1/4, right? And from the second branch, it actually tells us when a is 1/4, we have b must be 0, right? So by considering all these situations, therefore, possible solutions of a and b is either a is 0 and b is 0, or a is 1/4 and b is 0, or the third solution here, right, which is the same as second solution, so we don't have to repeat it. That means we only have two sets of solution, right? And therefore we can make the conclusion. The possible numbers are, there are two possible numbers, right? Possible numbers are 0 or 1/4, right? Okay, any questions? Yeah, I can see that you didn't make the final conclusion, right? I think, yeah, you get the A and B correctly, but forget to make the final conclusion. So usually you have to let your readers know what you're solving for, okay? All right, so first of all, I'll upload my notes onto Google Classroom in case you need it after the class. Okay, I'll upload it here. Let's go with assignment 66. All right, so as I said, we are moving to the next chapter. We still have a little time, so I'll make a brief introduction to you about our next assignment, okay? All right, so first of all, I'll upload it to Google Classroom as well. Where's Google Classroom? Google Classroom. This one. No, this is Dora's. This is yours. Okay, let's call this assignment 67. And this is about chapter 13, part A. And the deadline is next Monday, 11 o'clock, okay? Can you download it and print it out? Sorry about this. This should be 67, not 66. Okay, I'll give you some minutes and please download and print it out, okay? Okay. All right, so the new chapter is about how to solve the quadratic function. Okay, so actually we have already touched this a little bit in previous chapters. For example, if we have a quadratic function like this, x squared minus 5x then plus 6 equals 0. How do we solve this? Can you recall? So basically, we need to factor it, right? So how do we factor this expression? Do you remember that we can use the trial and error method, right? First item can be factored to x and x. And no 6 here can be factored to -2 and -3, right? And by cross multiplication, you will get -2x minus 3x, which is -5x, right? Which is a term in the middle. So that means this can be factored to x minus 2, x minus 3 equals 0, right? So there are two solutions, which is x equals 2 or x equals 3, right? And in chapter 13, we're dealing with equations like this. So for example, if we have another equation like this, usually an equation like this with this form cannot be factored easily, right? You can try it by yourself. It cannot be easily factored. So in this situation, we can use a method called quadratic formula, all completing the square. Okay, we can use either completing the square or quadratic formula. There are two methods to solve a function like this. Okay, so if you are not familiar with this, just try your best to complete as many questions here as possible. Okay, and I'll give you the solutions starting from next week. I'll spend several weeks on this chapter. Okay, and for example, I'll show you the first one. Find OX that satisfy the equation x squared equals 12 equal x squared minus 12 equals 0. So any thoughts? How do we solve this? We can move minus 12 to the other side, right? So this is x squared equals 12, right? And what is x? X can be positive or negative square root of 12, right? Which is positive or negative twice of square root of 3, right? Okay, so try our best to finish as many as possible. And okay, probably I'll show you another examples. So let's have a look at question 2. So note here, according to the formula, x squared plus 2x plus 1 can be rewritten as x plus 1 squared, right? So if you want to solve this by using the completing square method, first of all, we need to have x squared plus 2x, which are already there, right? And we need another term that is 1, right? But note there is no 1 in the original equation, so we need to subtract it. And then note here there is another -7, right? So we can rewrite it like this: x squared plus 2x plus 1, and then -1, and then -7 equals 0. And this part here can be rewritten as x plus 1 squared, right? And -8 equals 0. And then x plus 1 squared should equal 8, right? You follow me? Okay, so what's next step? Then our next x plus 1 should equal positive or negative square root of 8, right? And then we can solve our x. Okay, I'll give you, I just gave you these 2 examples to help you solve such questions. And if you still have any questions, let's discuss them in our next lesson. All right. Okay. So anything you want to ask for today? Will it be square? Which one? This one? Okay, let's start from here. So you have x plus 1 squared equals 8, right? And x plus 1 should equal positive or negative square root of 8. And x should be -1, positive or negative square root of 8. And usually we'll write it like twice the square root of 2, right? Okay. Okay, any more questions? Okay, perfect. So if you don't have any questions, you are free to leave. Okay. Have a nice week. Have a nice evening.